So we've done a little bit of review now on using right triangle trig, so sine, cosine, tangent, cosecant, secant, cotangent, to be able to find missing angles and sides and stuff like that. But not all triangles are right triangles. So we have these two, well, there's actually three of them. We're looking at two of them. We have these two laws. One of them is law of sine, so we're going to be using the sine ratio, kind of. And then we're going to be using cosine as well. So we're going to use the idea of the sine ratio to kind of establish this for you, but then we're going to transition completely to this new, basically, formula. So what we know is that if you have an oblique triangle, so you've got three sides, three interior angles, you don't have to have a 90-degree angle. Any angles will work, actually. The ratio is that you have sine of the angle over its corresponding side. So we know that if you start at angle A, its partner is going to be across from it. And then we're going to refer to capital letters being the angle themselves and lowercase letters being the side length. But then you can see it with all of the other ones as well. So like if you started at capital B and then side B is opposite from it. And then we can do the same thing with C. So basically what law of sines says is that if we have a non-right triangle, although this still works for right triangles, that as long as we have a pair, so if we've got capital A, then we would want little a as well. So we want a complete ratio. So maybe we've got big A and little a, then we can use sine of big A over little a. Remember, you only do like sine, cosine, tangent of actual angles, which is why we've got the big A or the angle for the sine. But you want a complete ratio. So maybe you've got A's. Well, maybe you've got B's. So then we would do sine of B over B. Maybe you've got C, do sine of C over C. The key here is that you have a complete ratio. Now, just because you have angles and sides, that doesn't mean you have a triangle for sure. Like, we know that there's still rules with triangle sum, so that the three interior angles have to add up to 180 degrees. So we would also have to check that and see, like, okay, well, you've got a 100-degree angle and you've got a 92-degree angle. Well, it's 192 degrees. You don't have a triangle. You can't have a negative angle when you're actually creating a triangle. So we have these new ratios, basically. So we've got sine of A over A, sine of B over B, sine of C over C. All three of them have to be the exact same ratio. That doesn't mean they're the exact same number. It means that when you compare the sine of the angle to its corresponding side, you have to get the same comparison. So like 2/3 for all three of them. So it's just the ratios have to be the same. Now, we also get into this possibility of maybe you have more than one triangle. So we're going to focus specifically on, is it a triangle or not? One, you make sure that it obeys triangle sum. Then you want to see, like, okay, well, what situation am I looking at here? If it is like two sides and one angle. If you have side angle side, so way back in integrated one, you don't have a complete ratio. Side angle side would be like big A, little b, big C. You don't have a pair of A's or a pair of B's or a pair of C's. So law of sines isn't going to work. That doesn't mean that you can't solve it. It's just you can't use law of sines. Then we've got side angle. This should look familiar from back in integrated one, when we couldn't use side angle or angle side as one of the triangle congruences, because there's a possibility that you technically have two triangles that satisfy the given information. So we'll talk about that in a minute. Then we've got two angles and one side. So angle, side, angle. We have either one or no triangle exists. Again, you want to make sure that triangle sum is satisfied and that, like if you're going to use law of sines, you have to have a pair. So big A, little a, big B, little b, big C, little c. Then we've got area of an oblique triangle. So remember, oblique triangle means we don't have necessarily a 90-degree angle. So we can't do like half base times height, because we don't know what the height is. Height comes from the 90-degree angle. So, or it's where a perpendicular side comes down from a corner and creates a 90-degree angle. So we're going to talk about the area of an oblique triangle also. Okay, so where does this thing actually come from? So we take a look at this. So I just pulled out an oblique triangle. I do want to use what we already know. So I'm going to go through and I'm going to identify ABC. Okay, so let's say that this is A, big A, which means opposite that is little a. I'm going to call the top here big B. I'm not going to label the bottom for a reason. I'll get there in a second. And then little c. Okay, so I want to use this idea of height. So I'm going to draw a line segment straight down, and I want that to be the height. So again, height perpendicular. So let's call this H. All right, well, if this whole thing was little b, I'm going to split this up into two pieces. Now, I can't call it like half b, because I don't know that they're the exact same size. So I'm going to call this X, this length here. And then I'll call this length here. Well, if the whole thing is b and X has already been taken, then this is going to be b minus X. I'm going to see if I can convince you where law of sines comes from. Now, we could have drawn the height from A, so capital A, down to little a. We could have done that also if we turned the triangle sideways, or capital C to little c. But I'm just going to do it this way. So if I take a look at the left-hand side triangle here, so I'm looking in this triangle right here, and I am going to see if I can come up with a ratio that uses sine of A, big A, and the H, which I can do. So I know that sine of big A in this triangle on the left-hand side is going to be opposite over hypotenuse. So using what I already know about like sine, cosine, tangent. Okay, I'm going to do the exact same thing on the other side. So this is going to be sine of big C is equal to H over, well, the hypotenuse here is little a. So I have two sine ratios. Okay, let's go ahead and cross multiply this. I'm going to solve for H. So if I cross multiply here, this is going to be C sine A is equal to H. And then this one over here, cross multiply, is going to be A times sine C is equal to H. Well, they both came from the exact same triangle, so the H has to be the same. So I can actually set these equal. So I know that I've got C times sine A is equal to A times sine C, since they're both equal to H, basically doing substitution. Okay, I'm going to manipulate this just a little bit so that I've got like the pair on the same side. So big A with little a, big C with little c. So I'm going to divide by C to get those to cancel. So that's going to give me sine of A is equal to A times sine of C all over C. Okay, I'm going to do the same thing. I'm going to divide by A so I can get those to cancel. And I could have done it at the exact same time. So this gives me sine of A over A is equal to sine of C over C. So there's part, and like the reason why we have the ability to do law of sines. So if I dropped the height somewhere else, then I could have also done sine of B over B. So remember, it's sine of the angle over its corresponding, or its like complete ratio side. Okay. All right, moving on. So if we take a look at this type of information that's given to us, you definitely might want to consider drawing a picture. So I'm just going to draw a triangle off to the side here. Now, I am not drawing this to scale for sure. So I'm going to put A here. That's 43 degrees. I'm going to put B at the top. That's 76. C, and then I know little a is 19. Okay, so I need to find everything. I need to find all of it. So I need to find lowercase c, and I need to find lowercase b, and I need to find capital C. So all three of those things. Okay, based off of the information that I have, again, using what I already know, I have two angles, which means I can find the third angle using triangle sum. So if I'm going to find big C first, so I'm going to find C. So remember, that's going to be 43 degrees plus 76 degrees plus whatever C is going to give me 180 degrees. If I go through and solve this, then I should be able to figure out what C is. So I'm going to use triangle sum here. So this is going to give me 119 plus C is equal to 180. And then I'm going to subtract. So C is equal to 61 degrees. Can the angle in a triangle be positive? Yes, of course it can. So if I take 43, 76, and 61 degrees, I can form a triangle. I would be super concerned if C came out to be a negative number. We don't want a negative angle when we're actually constructing these triangles. Okay, so we've got C. Well, if I take a look back at my picture, so using some triangle sum, if I take a look back at my picture, I have a pair. I've got the A's. So I have a complete ratio. So I know that I've got sine of, well, A was 43 over 19. Now you can set up all of the ratios and just decide which one you want to use first. So sine of B over little b equals sine of C over little c. Now you don't want to put all three of these together at once. Whatever you do or whatever you choose to solve for, you need to use the complete ratio. So let's say I want to solve for B. So I'm going to solve for B. Well, second, I already found C first. So this is going to give me sine of 43 over 19 is equal to sine of 76 over B. I'm going to cross multiply. So I get B times sine of 43 is equal to 19 times sine of 76. I'm not going to grab my calculator at all until I have B equals at the very end. Cross those out. So B is exactly 19 times sine 76 all over sine 43. So when I grab my calculator, remember, you can use that fraction option that we talked about in class. So it's the green button, the y equals, and then the first little menu that pops up. Or you can use parentheses and put parentheses around the 19 times sine 76, and then just hit the division symbol also. So either way, when we type this in, we are going to get B is 27.0317. Now, I don't care if you round or truncate. It doesn't matter. I do need you to be accurate to 3 decimal places. So you'll see on answer keys when I do stuff in class, you could see, well, I'll put 4 digits so you can check and see if you're right. I'll take 27.031 because that's truncating, but I'll also take 27.032 since that's rounding. They're both technically accurate to 3 decimal places. Okay, so I've got B. All right, so complete ratio with B's, I just need to be able to find C. So let's find little c now. Go back and use the exact same complete ratio, the sine 43 over 19. So I've got sine 43 over 19 is equal to sine 61 over c, cross multiply. And I think after a while, with a little bit of practice, you'll be able to kind of jump over this step. So I'm just going to divide here. So I will show my work since we're kind of close to the beginning of this unit still. Those cancel. So I'm going to get the exact value for C is 19 times sine 61 all over sine 43, but the approximation is going to give me 24.3662. And it doesn't matter if you round or truncate here. The C is going to be 24.366. Okay, so we found the missing sides. Let's throw in area just for kicks. So I'm going to go up here to the top right. So what color? I'll do red. So with area of an oblique triangle, we can do the half AB sine C, half BC sine A, half AC sine B. It doesn't matter which one you use. My recommendation is use as much of the original given information because it was exact. Like, we definitely do not want to use a rounded or approximated answer to get another answer. That's bad news. So if I take a look back, I have, what exact values do I have? Well, I don't have enough exact values. Okay, so let's go back here, and I think I'm going to use B. So in my calculator, I have this 27.0317, blah, 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 blah. Okay, I'm going to go back and retrieve that exact answer, or you can actually store it in your calculator. So let's go ahead and use that store option. Whenever I store something, I write looks like a little button like you would see on a keyboard, and where I put it. So since it's letter B, I stored it in letter B. Okay, so I'm going to use that then. All right, so now I'll go back. Let's do area is equal to half AB sine C. All right, so this is going to give me a half. Well, I know what A is. It was given to me. It's 19. B, I don't know. So this is where I'm going to use the B button where I stored the entire value for B. And then I've got sine. I know the exact value of C. It's 61. That wasn't an approximate. So now I'm just going to type the whole thing in my calculator and see what I get. So my area is going to be approximately 224.6038 units squared. So if you do this accurate to 3 decimal places, you could give me 224.603 if you truncated, or 224.604. I'll take either. It doesn't matter. Okay, let's take a look at this next one. Okay, so I take a look at the given information. I draw a picture. So I'm going to do the same thing that I did. I'm going to put A down here. Yes, I know it doesn't look like 117 degrees. It's not going to be drawn to scale. And then I've got B is going to be 93. C is going to be down here. And then little b is across from big B, so it's 67. I have the same situation as before. I've got two angles. May as well just do triangle sum. So I'm going to do triangle sum to find, let's do C here. So let's find C, a triangle sum for C. So that's going to be C plus 117 plus 93 is equal to 180. I'm already worried about this. I went through and I solved and I got C is equal to negative 30 degrees. Nope. So no triangle exists. For these problems, we don't want a negative angle. We don't want negative side lengths either. If you get a negative angle or negative side length, we've got major issues. You're not dealing with a triangle. You're just dealing with bits of information that somebody gave you. Your job is to say, no, it's not a triangle. Okay, so the two triangle possibility. All right, let's take a look at this. So let's say the given information here was that you were given that A is equal to 35 degrees. I have that little a is equal to 37. And I have that little b is equal to 55. Now, you'll notice that the A, B, C are in different locations than what I've been drawing. It honestly doesn't matter. Remember, the picture is just to help you. It's not necessarily going to be drawn to scale. Okay, so if I take a look at this information, I don't have two angles. So doing triangle sum is not helpful to me. But I do have a complete ratio. I've got a pair of A's. So I'm going to go ahead and set this up. So set up my complete ratio, which is going to be sine of 35 over, which is going to be 37 Now, I don't know anything about C. I don't know big C, I don't know little c, so I'm just going to ignore them for the time being. Yes, I know I have to find them, though. So this is going to give me sine of B over 55. Okay. Now, I also know, and even if you don't draw the pictures, it's fine. I also know that there's a chance that I am going to have two triangles here, because what's been given to me is angle side. So I've got angle leading to a side, leading to a side in consecutive order. So if I have angle side side, or side angle, however you want to look at it, it's a possibility of two triangles. Okay, so how do you find it? Well, or even if it does exist or not, just assume that a second one exists. The math will tell you, no, it's not going to work, because you'll get like a negative angle or a negative side length, and that doesn't fly. Okay, so here, I'm just going to go ahead and start solving this. Make sure that this is even possible. So I'm going to go ahead and cross multiply. So this is going to give me 55 times sine of 35. It's going to give me 37 times sine B. You'll notice in this case, I'm going to divide by 37 again. So if you have a complete ratio here, so like this guy, and you're trying to find an angle, you may as well just leave the complete ratio as it is, because you're going to end up redividing by the 37 that you just multiplied by a second ago. So it's an extra step, an extra work that's not really necessary. Okay, so we've got 55 times sine 35 all over 37. This is going to be equal to sine B. Remember, so way back, when we're trying to find an angle, we're going to use inverse. So I'm going to do inverse sine here, which is on the exact same button as the sine button in your calculator. Just make sure you hit the blue button or the shift or the second. So this is going to be 55 times sine 35 all over 37 is equal to, well, inverse sine and sine cancel. So now we're just going to grab our calculator. Now, I'm also going to do storing as I go. So you'll see me draw little buttons off to the side so I can keep track of where everything was. Okay, so type the whole thing into my calculator. And so for B, I am going to get approximately 58.49708951. So I'm going to store this in my calculator as B so I can find it easily. So store it as B. Okay. If a second triangle exists, you want to try finding it right now. So don't wait. As soon as you find the first angle, we're going to call this B sub 1. Because B sub 1 is this angle. So back in the picture, B sub 1 is between that pink line and that black line on the bottom. If a second triangle exists, then it corresponds with that angle. So if I go over to the one with the dashed lines, so I still have the pink dashed line and the black dashed line on the bottom, this triangle with the dashed lines, so this guy over here, this is an isosceles triangle. So what I know is that this measurement here is going to be the exact same thing as that measurement there. They're going to be congruent to each other. If the second triangle exists, then this B2 angle that I'm going to mark in pink, this B2 angle is going to be supplementary. So B1, which is right there, and B2, which is right there, have to add up to 180 degrees. So this is where that whole like triangle sum will kind of like jump in your face and be like, no, you got a negative angle. This isn't going to work. So I am going to immediately go across, immediately. And I'm going to see if the second triangle has a chance. So B2 is going to be 180 minus B1. Or you can see it as B1 plus B2 is equal to 180. Okay, so I know B1, I stored it in B. And I'm going to use that button. I am definitely not going to type in an approximate answer to try to find B2. Okay, so I'm going to do 180 minus the value I just found. Okay, so this tells me that B2 is approximately 121.5029 degrees. Now I'm going to store it. I don't know if I need to use it again. I don't even know if the second triangle exists or not yet. It's when I try to find the next angle that does it. So I don't want to put it as C because I'm going to use C for something else. So I'm going to go ahead and put this in D. Now you can choose whatever letter you want. You have the whole alphabet looking at you. So I'm going to go ahead and store this as D. So my 121.5029105. Know that there's more values after that. Your calculator only shows you a certain number of cells. Okay, now you can just finish the first triangle and then go back over to the second triangle, or you can do the second triangle. It doesn't matter. I am a big fan, though, of personally keeping these separate from each other. Now, the given information applies to both triangles. That hasn't changed. But anything on this left vertical line, any work is going to be in the first triangle only, so my triangle on the left-hand side. Any work on the right-hand side goes to my second triangle on the right-hand side. I'm not going to send them back and forth. This whole drawing the line across, the pink arrow, that's the only time I'm doing this. So I'm just going to go ahead and finish my first triangle. Okay, so I have big A, little a, that's given to me. I just found big B1. Little b's given to me. I think I can find big C1. Okay, so let's find C1. There's a handful of ways that you could do this. You could do law of sines again, or you can just do triangle sum. Actually, you can't do law of sines because you don't have little c. Let's do triangle sum. Okay, so triangle sum here. So I know that this is going to be A, which was 35 degrees, which was given to me, plus B1, which I stored in B, plus big C1 I'm trying to find, which is 180 degrees. So I'm going to go ahead and solve for this. This is going to be 180 minus 35 minus B that I stored. So C1 is going to be approximately 86.5029, 1049, blah, 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 blah. I'm pretty sure I'm going to use this again. So this I'm going to store as C. So go ahead and store it. Okay, so that's stored. Okay, so first triangle, big A, big B, big C, done. Little a, little b, yes, we need to find little c. So use the complete ratio that was given to you. So the A ratio. So we know that's going to be sine of 35 over 37. Sine of C, which I now know C, and then little c1. Okay, so I'm going to cross multiply. So I'm trying to find little c1. So this is going to give me c1 times sine of 35 is equal to 37 times sine of whatever I stored in C, and then I'm going to divide. So this is going to give me 37 times sine of C all over sine of 35. Okay, I'm going to go ahead and type this in. So if I go ahead and set up my fraction, it's going to be 37 sine C that I stored all over sine 35. Oh, also, of course, when you're dealing with degrees, make sure that your mode was in degrees to start. Okay, so little c1 is going to give me 64.3874. Okay, so let's see what I got here. I'm going to kind of box my answers so I can see them. All right, so I have big B1. I have big C1, and I have little c1. So if I did this and it's completely done with the first triangle, I was given 3 pieces of information. I just found 3 more pieces of information. Every triangle technically has 6 parts. three sides, three angles. Okay, now let's go over to the side, the pink side. I still don't know if the second triangle exists. It's triangle sum that is going to help me figure that out. Okay, so let's find C2 if it exists. And this is going to be triangle sum. Okay, so C2 plus A, which was given to me, which was 35, plus B2, which I saved as D, has to give me 180 degrees. Okay, let's see if this thing actually works. So get 180 minus 35 minus what I stored as D. If this is positive, then you have a second triangle. If it's negative, you don't have a second triangle. If it's 0, you definitely don't have a second triangle. This one, though, this one works. C2 is approximately 23.49708951. Okay, I'm going to store this. Well, where have I already stored things? I don't want to step on the toes of things I've already stored. So I've got B, C, D has been taken. Let's call this E. So I'll go ahead and store this as E. Okay, so what do I have here? I have B2. I have C2. I have big A, little b. I need to find little c. Okay, so complete ratio that was given to me, sine of 35 all over 37 is equal to sine of, okay, this is going to be C2, which I stored in E, all over little c2. Okay, I'm solving for c2, so I'm going to cross multiply. Sine 35 is equal to, let's try that again. 37 times sine of E, and then I'm going to divide. So C2 is 37 times sine of E all over sine 35. All right, let's type this in. So set up my fraction, 37 sine E, and I am actually using the E letter in my calculator. I'm not typing in an approximation. Divided by sine 35, this is going to give me 25.7193. Now, since it is the last thing I am finding here, I don't need to store it. So for the first triangle, I found B1, C1, and then little c1, and then I found B2, C2, little c2. Really, the thing that you need to look at here is, does supplementary work? If supplementary gives you a positive angle, there's a chance. But if B2 is positive, it's really C2 that seals it for you. If C2 satisfies triangle sum, and it's not negative or 0, you have a second triangle. Okay, so what we have set up here is the same thing that we did on the previous. So you notice I have a pair of A's. I do not have two angles. I just have one, which means the whole idea of using triangle sum from the jump is not going to satisfy this problem. So I highly recommend that you pause at this point. The only thing you can find right now is big C1, assuming that there is two triangles. So why don't you see if you can set it up, cross multiply, solve, round or truncate, accurate to 3 decimal places, doesn't matter to me, and then unpause it and see if we match. Okay, so I ended up with sine of 55 over 9. That's the complete ratio that was given to me. And then sine of C1, I'm just going to assume there's two triangles, over 10, cross multiplied. And then because I'm looking for an angle itself, I'm going to use inverse sine. So I ended up with 65.5287 as C1, and I stored it as C. Now, you don't have to clear out whatever you stored before. It just stores right on top of the old thing. So it does like a delete replace. Okay, now is when we determine if the second triangle even has a fighting chance. So first angle that you find, jump across. So I'm going to jump across over here. And remember that I'm going to be doing supplementary, and I'm going to split this now so I don't go from one triangle bouncing back and forth. I know that drawing the line helps me a ton. If it does for you, great. If it doesn't, don't worry about it. This is just a me thing. Okay, so I'm going to do supplementary now. Okay. Now remember, if this ends up being negative, then there's no second triangle for sure. If this ends up being 0, there's no second triangle for sure. Then if the triangle sum, so if those both work, then we check triangle sum. But again, you can just finish the first triangle first. Okay, so I know that this is going to be C1 plus C2 has to give me 180 degrees. Okay, well, C1 I stored as C plus C2 is equal to 180. So I'm going to do 180 minus what I stored as C, which was my C1 angle. This is going to give me 114.4712 degrees. Not negative, not 0. Okay, I've got a fighting chance. I'm going to store that as D, and then I'm going to come back to it. I'm just going to finish the first triangle, so I'm going to bounce back. It doesn't matter the order that you do this, as long as when you find the first angle, immediately find supplementary. This is what gets you, so this pink arrow right here, this is what gets you from triangle 1 to triangle 2. You want to do it ASAP, like it's the second thing you find. Okay, back over. Okay, so let's find B1. So I'm just going to do triangle sum. Okay, so if I go through and do triangle sum, remember this is going to be 55 plus angle C. I'm on this side, so make sure I use that button. Plus B1 is going to be equal to 180 degrees. Okay, I ended up with B1 is approximately, looks like 59.4712 degrees. I am going to store that as B. Now, if I want to finish this, the next thing that I would find is little b1. So why don't you set up little b1? Remember, use the complete ratio of what was given to you. You're not going to use any C business at all because we're not trying to find C, we're trying to find B. So set up the ratio, see if you can find little b1. Okay, so I did sine of 55 over 9, that's my complete ratio, and then sine of b1, which I put on button B, over b1, cross multiplied, solved. Looks like I got 9.4638. Okay, so I'm going to go ahead and use my highlighter. Let's do like a bluish green for the first one. Okay, so there's C1, there's B1, and then there's little b1, which go ahead and fill into the answer blanks on the side too. Just make sure you keep track of which one's which. You know what, may as well find area too while we're here. And I don't think I need to keep little b1, so I'm not going to store it. If you're not sure, store it so you don't lose it. Okay, so let's find area 1. Well, it doesn't matter what you use. I think I'm going to do half AC sine B. And B was on a button. Okay, so this gives me half AC sine B. Type it in. It looks like the area is going to give you 38.7618 units squared. Remember that you can round or truncate, so 38.761, 38.762. It's totally up to you. Okay, now let's see if the second triangle exists. Triangle sum immediately. Let's see if it works. Okay, so we already had A. We've got C. Let's find B. So find B2. We're going to use triangle sum. And you don't have to write the triangle sum business here. I'm only doing this for our notes. So we know that it's going to be B2 plus angle A that was given to us, which is 55, plus angle C2 we just found that I stored as D has to give me 180 degrees. All right, if B2 is not negative and not 0, so positive, then this is going to work. This gives me 10.5287 degrees. I'm going to store that as E. And then why don't you pause and see if you can find little b2 and then come back and check. Okay, So we end up with 2.0076, which you could do 2.007 or 2.008. All right, let's highlight this and see what we got. So we'll use like this pale pink here. So let's see, we've got little c2, big c2, big b2, little b2. Why don't you see if you can find the area and then come back and see if we match. Okay, so for the second area, I got 8.222 units squared or 8.223. It's totally up to you. The example 4 and the example 5 are going to be how we start our next class.